If it is cosecant A, we can write it as 1 by cosecant A is sine A. Cosecant squared A means 1 by sine squared A is cosecant squared A. 1 minus sine squared theta can be written as cos squared theta. 1 minus sine squared A can be written as cos squared A. Now you know that trigonometric identity is nothing but what? 2 into 1 plus cot squared A is cosecant squared A. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram, the Temple of Excellence, Mysuru. In the last session, what we have learned? We have learned so many problems on trigonometric functions, isn't it? What are the trigonometric functions, dear? Sin theta, cos theta, tan theta, secant theta, cosecant theta and cot theta. These 6 trigonometric functions are there in a trigonometry, and in this session we are going to have angles and trigonometric ratio, which is nothing but the chapter number 13, and this is a session 4 you are going to have. And what are the topics we are going to study under this session is nothing but problems on trigonometric identities. What is a trigonometric identities is going to be known as, that means sin squared theta plus cos squared theta is equals to 1. Theta is an angle. 1 plus tan squared theta is equal to secant squared theta. Again, you are going to have 1 plus cot squared theta is equal to cosecant squared theta. Similarly, you can have it as sin theta can be written as 1 over cosecant theta. Cos theta can be written as 1 over secant theta. Tan theta can be written as 1 over cot theta. Otherwise, vice versa. Reciprocal of sin theta is cosecant. Reciprocal of cos theta is secant. Reciprocal of tan theta is cot theta. So, similarly, tan theta can be written as, tan theta will be is equal to sin theta divided by cos theta. Okay. Similarly, you are going to have cot theta can also be written as cos theta divided by sin theta. Okay. So, all this trigonometric identities and also reciprocals of the trigonometric function you should know to solve the problems. Understood? So, we'll move on to the problem now. Prove that cos A into tan A is equals to sin A. So, what tan A can be written as here? I am going to take the left hand side LHS, and then I am going to have it as cos A into tan A can be written as sin A divided by cos A. So, which will be cos A will get cancelled. You are going to remain with only sin A. So, which is nothing but your RHS, right hand side. That's it, the proof. Understood? We'll move on to the next one. Prove that tan A into cosecant A into cos A is equals to 1. So, tan A can be written as what? I am going to take the left hand side. So, left hand side, and then I am going to write tan A is equal to sin A divided by cos A into, you are going to have cosecant A can be written as what? It is nothing but 1 divided by sin A, isn't it? Into cos A, as it is I am going to write it. So, dears, you can see here sin A will get cancelled, cos A will get cancelled. So, 1 into 1 will be same. So, 1 will be the your RHS, right hand side. Understood? These questions will be asked for either 1 marker or maybe for 2 marker. Understood? We'll move on to the next problem. Prove that 1 minus cos squared A into cosecant squared A is equals to 1. So, they have given 1 minus cos squared A is nothing but you can write it as, see, identity you know that sin squared theta plus cos squared theta is equals to 1. If you take cos squared to that side, it will become 1 minus cos squared theta can be written as sin squared theta. Now, in place of theta, they have given it as is nothing but only A, cos squared A. Therefore, see, 1 minus cos squared A can be written as what it is. It is nothing but sin squared A, correct, into See, cos squared A, cosecant squared A can be written as what? Reciprocal of sine, which is nothing but 1 divided by sine squared A, because they have given here cosecant squared A. If it is cosecant A, we can write it as 1 by cosecant A is sine A. Cosecant squared A means 1 by sine squared A is cosecant squared A. So here sine squared A will get cancelled. You are going to remain with only what it is. Here left hand side I have taken. I have proved the right hand side, which is nothing but 1. That's it. I'm using the identity. Are you getting this? We'll move on to the next one. What they was, prove that 1 plus tan squared A into cos squared A is equals to 1. Same like LHS, I am going to take it as here, which is 1 plus tan squared A into cos squared A. Now dears, I am going to use again the identity. You know that 1 plus tan squared A is nothing but what? That is theta is equal to secant squared theta, correct? So therefore in place of theta you are having here A. Therefore I can write this one as 1 plus tan squared A is secant squared A into cos squared A. Either you can write cos squared A in terms of secant, or you can write secant squared A in terms of cos as a reciprocal. Therefore you can write here secant squared A can be written as 1 over cos squared A into cos squared A as it is. So these two will get cancelled. You are going to remain with the 1, which is nothing but your RHS. Correct? I think you understood this proof by the identity. That's it. We'll move on to the next question, dears. Prove that 1 minus sine squared A into 1 plus tan squared A is equals to 1. Here we'll be using the two identities, which is nothing but sine squared theta plus cos squared theta is equal to 1. They have given 1 minus sine squared. Bring sine squared to that side. It will become 1 minus sine squared theta can be written as cos squared theta. Similarly, you know the identity 1 plus tan squared theta can be written as secant squared theta as we written in the last problem. So here in place of theta you are having A. So therefore I can write it as 1 minus sine squared A as cos squared A. Again 1 plus tan squared A as secant squared A into secant squared A. So therefore dear students, you are going to have it as here. Cos squared A can be written as 1 by sine secant squared A, or secant squared can be written as 1 by cos squared A. So therefore here taking the LHS, we have proved, which is nothing but here 1 by secant squared A, I can write it. Otherwise this you can write it as secant squared A can be written as 1 over any 1. So secant squared A will get cancelled. You are going to remain with the 1, which is your RHS. That's it, dears. I hope you got this one by using the identities. We'll move on to the next one, dears. What they've asked, prove that cos squared A tan squared A plus cos squared A is equals to 1. So what I can take here, see dear students, from these, see cos squared A is there, cos squared A is there. I can take common out of that. So if I take common, what it will be, taking LHS, in the LHS taking cos squared A as common, cos squared A into, here remaining is tan squared A plus here remaining is 1. So you know already 1 plus tan squared A can be written as secant squared A. So therefore, you are going to write that one cos squared A into, this is nothing but secant squared A. Now any one of them you can write it as a reciprocal. Therefore you are going to get the answer 1 by secant squared A into secant squared A. Cancelling, you are going to get the answer as 1, which is your RHS. Correct? You understood? By taking cos squared A as a common. We'll move on to the next one. Next they have asked, prove that 1 minus sine squared A into secant squared A is 1. What is 1 minus sine squared A? You know, according to the trigonometric identity, sine squared theta plus cos squared theta is equal to 1. So 1 minus sine squared theta can be written as cos squared theta. 1 minus sine squared A can be written as cos squared A. Therefore, by taking the LHS is equal to this 1 minus sine squared A, I am writing it as cos squared A into secant squared A. Now any one of them you can write it as a reciprocal. Cos squared A only I can write it into secant squared A. So these two will get cancelled. You are going to remain with the answer 1, which is your RHS. Correct? These are all very easier problem by using the trigonometric identities. Just we are going to solve these questions. Okay? We'll move on to the next one. Prove that secant A minus cos A is equals to tan A into sin A. So therefore here secant A can be written as 1 divided by cos A, reciprocal. Now by taking the left hand side, will be is equal to secant A, I am writing that, minus cos A can be written as secant A is 1 over cos A minus cos A. So which implies that you are going to have it as cos A into cos A by taking LCM. 1 minus cos A is the LCM. Cos A into cos A is 1 is remaining, 1 minus cos squared A. Now you are going to have 1 minus cos squared A can be written as sin squared A by the identity. So therefore sin squared A divided by cos A. Now you are writing sin squared A as sin A into sin A, isn't it? You can write sin A into sin A. X into x is x squared. Sin A into sin A is sin squared. So divided by cos A. Now sin A by cos A you collect one where, because they have given tan A to prove, into you are going to have sin A as it is in the numerator. What is sin A by cos A? Sin A by cos A is nothing but your tan A into sin A. That's what they have asked you to prove, which is your RHS. Is that easier, dears? So by taking the trigonometric identity, we have proved the RHS is the answer. That's it, dears. We'll move on to the next question. What they have asked, prove that cos A plus sin A whole squared plus cos A minus sin A whole squared is equal to 2. Let me do this one, dears, here. Let me take cos A plus sin A whole squared is nothing but A plus B whole squared. What is A plus B whole squared? A squared plus B squared. So let me write A plus B whole squared. A plus B whole squared is A squared plus B squared plus 2AB. Now by taking A as cos and B as sin here, I can write it as cos A whole squared is cos squared A plus sin A whole squared is sin squared A minus 2 cos A into sin A, because A is nothing but this one. Let me write A is this one and B is this one, sin A, plus 2 sin A into cos A, or 2 cos A into sin A, isn't it? If you multiply either 2 into 3, 3 into 2, both are same. So plus, again this is nothing but A minus B whole squared. A minus B whole squared is A squared, that is cos squared A plus sin squared A minus 2AB, that is 2 cos A into sin A or sin A into cos A, correct? Therefore, you are going to have here, see, plus 2 sin A cos A minus 2 sin A cos A will get cancelled. This I am taking here LHS to prove. So which happens here, see, cos squared A plus sin squared A. Cos squared A plus sin squared A, what it will be? You know it is an identity which is equal to the value 1. So 1 again plus 1, which will be implying that 2, which is your RHS. Very easier. Only expanding in terms of A plus B whole squared, you are going to get the right hand side answer. Is that easier? This type of questions will be asked for a 2 marker. Just you have to use your brain to solve. That's it. We'll move on to the next one. Prove that cosecant A minus sin A is equal to cot A into cos A. As like what we have done before the problem, as cosecant A, left hand side I am taking. Cosecant A can be written as 1 divided by sin A. Reciprocal of sin is cosecant, reciprocal of secant is cos. So here 1 by sin A minus sin A. So here taking the LCM as nothing but the sin A. Now sin A into sin A is nothing but 1 minus sin squared A. 1 minus sin squared A, which will be, what is 1 minus sin squared A can be written as, you know, sin squared theta plus cos squared theta is equal to 1. 1 minus sin squared theta is cos squared theta. 1 minus sin squared A is cos squared A. Therefore, cos squared A divided by sin A. Now what you are doing, dears? You are going to split this one. Cos squared A can be written as cos A into cos A. Cos A into cos A divided by sin A. Now I am going to rewrite the terms as like this. One term I am going to write it as cos A divided by sin A. Another term of cos A remains as it is. Now what is cos A by sin A? It is nothing but cot A. Sin by cos is tan. Cos by sin is cot. Therefore, cos A by sin A is cot A. Cot A into cos A, which is your, see, which is your RHS. That is the proof. Got? I hope you got this problem. We'll move on to the next one. What they was, prove that tan squared A plus secant squared B is equal to secant squared A plus tan squared B. So let me take this one only, tan squared A and plus secant squared B. So I am going to write this one as taking LHS. What is that? Left hand side, tan squared A plus secant squared B. Correct? Tan squared A plus secant squared B, I can write it as 1 plus tan squared theta can be written as secant squared theta, or secant squared theta minus 1 can be written as tan squared theta. Any of the form I can reduce this formula. Okay. Now I can write this tan squared A as what? You are going to write it as secant squared theta minus 1, which can be written as secant squared A minus 1. So plus secant squared B. Correct? You are going to have it as. Now this secant squared A can be written as 1 by cos squared A, and this can be written as 1 by cos squared B. Now you have written this one tan squared A as what? Secant squared A minus 1 plus secant squared B as it is you are writing. Now what is secant squared B can be written as like that, 1 plus tan squared theta. In place of theta B you are having, therefore which implies secant squared A minus 1 plus this can be written as 1 plus tan squared B. Correct? Be careful. This I have written in the form of secant squared theta minus 1, and this I have written in the terms of 1 plus tan squared B. So therefore your minus 1 plus 1 you are going to get cancelled. You are going to remain with the answer secant squared A plus tan squared B, which is your right hand side answer, isn't it? So secant squared A plus tan squared, minus 1 plus 1 will get cancelled. Is that easier? By using the trigonometric identity only, just we have solved this problem. We'll move on to the next one. They were asked to prove that 1 plus cot A whole squared plus 1 minus cot A whole squared is equal to 2 cosecant squared A. So here you can have it as either by having the identity or by solving by putting A plus B whole squared, A minus B whole squared. Let me take it as A plus B, A minus B whole squared because you are familiar with the formula. So 1 squared plus cot squared A B squared plus 2AB, 2 into cot A into 1, again plus 1 squared plus cot squared A B squared minus 2AB, 2 into cot A into 1, correct? So take considering LHS here. So you are going to have the answer here. See, you can have plus 2A minus 2 cot A plus 2 cot A will get cancelled, and then 1 plus 1 will be is equal to 2 here. 2 plus cot squared A plus cot squared A will be is equal to 2 cot squared A, correct? So therefore here will be is equal to 2 into, you can take 2 as a common factor, 2 into 1 plus cot squared A is remaining. Now you know that trigonometric identity is nothing but what? 2 into 1 plus cot squared A is cosecant squared A. So cosecant directly you are getting the answer if you do by expanding A plus B whole squared and A minus B whole squared, which is your RHS here, 2 into cosecant squared A. That identity you should remember. Understood? I hope you got this step. We'll move on to the next one. You have to prove that 1 by secant A plus tan A is equal to secant A minus tan A. Therefore, so here you are going to have it as, see, left hand side I am going to consider, which implies 1 divided by secant A plus tan A. Now by multiplying what? This conjugate. If you multiply this one, you are going to have into secant A minus tan A divided by secant A minus tan A, correct? Multiplying this conjugate, it will be giving you that, which implies that 1 into secant A minus tan A, secant A minus tan A divided by secant A plus tan A plus B into A minus B. What is A plus B into A minus B? A squared minus B squared, which is secant squared A minus tan squared A. But dears, observe here, what is 1 plus tan squared theta? It is secant squared theta. Now, taking this tan squared theta that side, you are going to have secant squared theta minus tan squared theta is equal to what? 1. So, therefore, denominator I can substitute secant squared A minus tan squared A is 1. So, which implies that secant A minus tan A divided by 1. Correct? So, divided by 1 means same thing in the numerator, which is secant A minus tan A, which is your RHS. That's it, dears. Okay. So, I hope you understood this one. We'll move on to the next one. What they've asked, prove that tan A plus cot A is equal to secant A into cosecant A. So, tan A can be written as what? Sine by cos, or you can write like this. A cot A can be written as what? 1 by tan. Anything you can write, or tan A can be written as 1 by cot. So, here I am going to write it as tan A as it is. Taking the LHS implies the tan A as it is. And this cot A, I am going to consider it as 1 by tan A. Okay, because the reciprocal of tan is cot. You know that. So, which implies tan A into tan A is tan squared A plus 1 divided by tan A. Now, what is 1 plus tan squared A? 1 plus tan squared A is nothing but secant squared A, isn't it? So, therefore, we are going to write that one. Secant squared A divided by tan A. Now, what they've asked you to prove? They've asked you to put secant A into cosecant A. Therefore, I can write this one as, see, secant squared A as it is I am writing into, see, 1 by tan A. Tan A can be written as what? Sine by cos, right? So, since it is in the denominator, 1 by tan will become cot. I am writing that here, cot A. And then cot A can be written as cos by sine. Are you getting? 1 over tan is cot A I am writing. Cot can be written as secant squared A into cot A can be written as cos A divided by sine A. Right? Now, which implies secant squared A can be written as 1 over cos squared A. 1 over cos squared A into cos A divided by sine A. Now, one term cos will get cancelled here. You're remaining with 1 in the numerator divided by cos A into sine A in the denominator. Now, you are going to split this one because I want secant A and cosecant A. So, 1 by cos A into 1 divided by sine A, which implies that. So, 1 over cos A is nothing but your secant A into 1 by sine A is cosecant A. That's it, which is your RHS. Is that easier, dears? Understood? Yes, dears. I hope you understood this step. We'll move on to the next problem. What they've asked, express all the trigonometric ratios in terms of sine theta, cos theta, tan theta. They've asked you to prove like that all the trigonometric functions, okay? So what they've asked, express all the trigonometric ratios in terms of sine theta, in terms of sine, cos theta, tan theta. You should express all this in terms of that, in remaining all except sine theta. Now, I am going to take as a first one, let x is equal to sine theta. If x is equal to sine theta, I am going to consider, you know, sine theta is nothing but given by opposite divided by hypotenuse. What is opposite is x, hypotenuse is nothing but denominator 1 you are having. So, in the right angle triangle, you can have hypotenuse is nothing but 1 and opposite is nothing but x. How to find out the adjacent side? So, hypotenuse squared is equal to opposite squared plus adjacent squared. Now, adjacent squared can be written as, adjacent squared is nothing but hypotenuse squared minus opposite squared, which implies hypotenuse is 1 minus x squared. Now, what is adjacent can be written as? Adjacent is nothing but square root of 1 minus x squared. Now, what is square root of 1 minus x can be written as? X is nothing but sine theta. So therefore, what is cos theta can be written as? Cos theta will be is equal to, so x is nothing but here sine theta 1 as it is, and root of 1 minus x squared is nothing but root of 1 minus sine squared theta. Okay, therefore, cos theta can be represented as what? Adjacent divided by hypotenuse. What is adjacent? Adjacent is root of 1 minus sine squared theta divided by hypotenuse is nothing but 1. So, cos theta can be written as root of 1 minus sine squared theta. That's it. Now, we'll move on to the same tan theta. How tan theta can be written as? Tan theta is nothing but opposite by adjacent. What is opposite? Now tan theta can be represented as opposite divided by adjacent. Opposite is x. X is nothing but sine theta. So sine theta divided by adjacent is root of 1 minus sine squared theta, which is nothing but cos theta. Sine theta by cos theta. Now you are going to have next is cot theta. Cot theta will be reciprocal of this is cot theta, right? I'm writing here cot theta is root of 1 minus sine squared theta divided by sine theta. Similarly, cosecant theta will be is equal to, you are going to have it as 1 by sine theta. 1 by sine theta is nothing but as it is 1 by x. Now secant theta, what is secant theta? 1 by cos, which is nothing but 1 by root of 1 minus sine squared theta. Is that easier? This is how you are going to represent by taking a right angle triangle and considering let x is equal to whatever. Same you are going to do cos theta also and tan theta also. Let x equal to cos theta, taking a right angle, and cos theta is adjacent divided by hypotenuse, taking adjacent as x, hypotenuse is 1, and proving all the trigonometric functions. Similarly, you are going to take tan theta. Tan theta is equal to x. So tan theta can be written as opposite divided by adjacent. Opposite is x and adjacent is 1. So prove all other trigonometry whatever it is. Understood? Okay dears, I hope you got this session how to solve the problems on trigonometric identities and also by using the reciprocals of trigonometric functions. Thank you dears. In the next session, we'll be solving some more problems based on this. Thank you dears.